welcome to the Pragmatic Innovator. Delighted to have with us today Luke McGuinness from Roush, where we'll be exploring with him a bit of his journey within the automotive industry, the changes that have been happening and that he's seeing, and as well as the impact that additive can have within the engineering space. So, Luke, I wonder if you could just introduce yourself real quick.
Thanks, Justin. I'm Luke McGuinness. I work in product development here at Roush Performance, which is part of the aftermarket group of the bigger Roush Industries here in Detroit, just outside of Detroit in Livonia, Michigan.
Tell me a little bit about you, Luke. I was Googling you actually, and I saw you were doing some F-150 kind of promos about 10 odd years ago for the F-150, and you're working on kind of similar projects now, but obviously moved them forward a lot. Tell us about those.
We're working on our new F-150 project at the moment here at Roush Performance, and I've been here at Roush for 25 years. Got into the automotive space, since I was a young boy. Wanted to work on cars, wanted to design cars, and when I got the opportunity to come and work at Roush, I jumped at it, and I never looked back.
Yeah, were you kind of one of those kids always wanted to tinker with engines, kind of bought your first car and putting on the go faster stripes, but also trying to kind of work that thing, get a little bit more power out of it and those sorts of things? Or did it come to you a little bit later in life, that sort of passion for motorsport and automotive?
No, I followed suit exactly like that. Got my first car was an F-150, a 78 F-150 was my first truck. And we pulled the motor out of it, put a new rear end in it, built the engine up in it. So since that journey, it's kind of been the same, the goal for more horsepower.
And so you started Roush 25 years ago, right? So did you start as like an apprentice? Did you kind of do that traditional automotive degree and then start after that? Or what was your journey?
Yep. So I started with a co-op term here at Roush, working in the powertrain group, which was a great opportunity, great exposure to the inner workings of the engine powertrain. And then when I was finished school in 2002, I came right on board with the powertrain group and started doing design work on probably one of the coolest projects a young engineer can work on, the 2004 Ford GT program.
So, Luke, I know you guys do a podcast called You Don't Know Jack, which I love the name of, obviously after Jack Roush, your founder. And I think you've been a guest on it. Can you tell us a little bit more there?
Yeah, Justin. It's called You Don't Know Jack, named after Jack. And one of the other hosts is Jack Jr., Jack's son. Okay. So it's just a podcast that we put together where we give customers a little more insight into the day-to-day of what goes on behind the scenes here at Roush Performance and Roush Industries, in general, to shed some light as to the capabilities and some of the things that we do behind the curtain on engineering services we provide to people.
How does it work in terms of what vehicles you select? Is it a bit of push, a bit of pull? Like, is it customers saying, or you get a pool of customers that want to work on their F-150s, or is it the manufacturers coming to you in some cases saying, look, we want a beefed up version? Or how does it work?
On our performance side, it started with Jack Roush back in the late 70s with drag racing, working on his Mustang, working with his team of engineers while he was at Ford before he left Ford to start his own company, Roush Performance. And at that point in time, Jack was, the engine guru. He could eke all the power out of these things. That caught the attention of Ford. That started building his relationship with the Ford and Ford Motorsports, Ford Racing. And then from there, the Roush brand has just been synonymous with Ford Performance. When people think of Roush, they tie it to that Ford brand. So that's, something that we focus on in terms of the product is, the Mustang, the F-150, some Bronco components, some Super Duty, and then based on the needs from our sales, what we hear from customers, that's where we do develop product to then meet their need for speed or styling or for their lifestyle, right?
And in terms of kind of the inquiries coming in from customers, how does that mix sort of work? And has it changed? People kind of thinking, look, I wanted to eke out more power, but perhaps now they're wanting to eke out more mileage per gallon or something like this, or
Right.
now it's more about the styling and the lighting and things like that. Has that evolved, like the aftermarket?
Oh, for sure, Justin. I mean, everybody's got different needs and wants within a car. There's still the horsepower junkies. They're looking for performance. That's why we continue to do our supercharger development. But then as well, you've got the styling of the vehicles. The like you noted, lighting is a big signature aspect of the vehicles, and that's something that we've been working on with our newest project on the F-150. The interior, the cabin of the vehicle, what the customer sees, what they touch, whether it's carbon fiber accent trims that we add, whether it's the upgraded audio system that we put in the vehicle. We kind of cater to the entire package for the customer, where they're looking for something a little different, a little unique, that says I live a performance lifestyle.
Yeah, yeah, yeah. I love that. Live the performance lifestyle. Talking about Roush as a company, you guys have been on quite the journey. I think it started with Jack, and there was that small kind of core team of engineers. I think I think I was hearing on the podcast 10 to 4,500
Yep.
employees now. Wow.
Yeah, it's the company's really grown, and
Yeah.
it's neat to see how we've got involved in different industries over the years, especially back in like 2008, diversification, where we were mainly an automotive company at that point in time. And since then, we've diversified into a multitude of different portfolios to support the business.
Yeah, I should also mention as well, you've got your 50th anniversary coming up in 2026 as a company.
Yes.
So yeah, quite the marker. And tell us more about how you've got into those other industries like defense, for example. How does that kind of conversation work? You guys are kind of thinking, look, we can solve some issues here for this industry, or is it more that they're coming to you guys saying, look, we need some expertise, can you guys help out?
Well, I think it's a little bit of both, but mainly the latter, where people come to us. We've got
Right.
a pretty good reputation within the industry for being the problem solver. The tagline, corporate tagline we've had for a couple of years was ingenuity on demand. We react, we come up with the solution. We're the man behind the curtain, where we'll do all the R&D work, then provide that solution, and then pass that off to our customers so that they can reap the benefit of the product or the technology, whatever it is that we've been working on them with.
Yeah, yeah, yeah. And is there a particular need there that they're trying to get? Is it kind of they want to get more power out of their engines, or is it they're just looking for that customizable, just some quality engineers really to kind of
Right.
fix their problems, design them and make them something for their needs.
I think it's mainly designing something for their needs, trying to find the talent that they're looking for to get them their solution. I'm not sure what some of the specifics would be in terms of some of those projects, but I know within the variety of the business units, you've got 100 engineers, you've got your business team, you've got your marketing sales team. So everybody's working together to kind of keep the new customers coming in and keep working with our current customers to keep them happy.
So tell me kind of day to day what you're working on at the moment. I know F-150 is something very close to you. Yeah. So tell us a little bit about that project and anything else you're working on.
Yeah. For right now, we're working on launching our 2024 F-150.
Mm-hmm.
And that entails everything from some revised chassis tuning, revised exhaust system. We've adapted the OE system to include our Roush active exhaust for the F-150. So now you can open and close the exhaust valve on your truck and give it a little more growl when you want, and keep it a little quieter when you try to leave for work early in the morning.
Well, the kids are asleep. Yeah.
Yep. Try not to wake up the neighbors.
Yeah. Yeah.
Big part of the Roush F-150 is the front end, the revised grille on the truck that we incorporate. And then, as I noted, on the interior cabin side, there's audio system upgrade. There's some accent trim carbon fiber pieces that we developed for the inside of the vehicle, revised leather seating that we put in the vehicle to spruce up the cockpit, some pedal covers, and of course, you got to have your serialized Roush badge put inside the cabin of the truck as well to let people know you've got a unique vehicle. So, but the day to day, it's working on it's product development for the components, whether it's working with the studio, like you see in the sketches and renders behind me. We'll start with the idea from the studio team where they come up with what it is that we want to bring to market or put out there as a product, and then we work with them to make sure that designs are feasible. There's a method of manufacturability, and that's actually what led to some of the joint work we've been using Stratasys for, where we come up with some parts where the die draw is really complex, or if we could make it in a different method, that would it would help the product. It'll help project timing, and the printing method is what really helps drive some of that. It reduces our development lead time, reduces tooling lead time, and then it gives us a product that's nettable and usable in a production vehicle.
How much pressure is on you guys for time to market? Is it kind of you've got like a set window, say Ford releases the 2024 F-150, it's like, guys, we gotta get this thing out in 3 months or 6 months, or is it kind of like you could maybe wait 12 months or something and that's okay?
No, that's a big part of it, is time to market and the market window, especially with the changing model years from the OE. So as soon as Ford releases their first trucks, it's been about 4.5, 5 weeks since we've got our first vehicles for the program, and we've had all our parts tooled, ready to go. And now we're doing our development validation on those to kick off production here in the next week for the new product line. So it's a real big push to try and keep that window open, so that way we get more selling throughout the entire season of that model year before Ford changes to the new model year. Whatever changes they have, then we have to react to that, and so on. And the cycle keeps going, and my hair keeps getting gray.
Yeah, absolutely. Everyone wants more in shorter amount of times, always, don't they? That's the way the world is going. So when you're looking at like a new vehicle or a new release, how are you picking like what you're going to change and what you're going to leave alone? Is there like a tick list that you're going down where you're thinking definitely wheel arches, definitely grille, definitely interior, we could do this with the exhaust system? Like, how are you putting together that package?
We've got a portfolio director that kind of gathers that information. We work with the sales and marketing team to see what are the wants of the customers, what's the feedback we're getting in the field, and looking at customers' trucks in the field, past customers, asking them what is it that you like about the truck, what would you see as an improvement, and where areas where we can add something more to the package to accessorize the vehicle. And one of those things on the new truck is lighting. We keep hearing that lighting is one of the bigger markets that's definitely growing. So for the new F-150, we put an integrated light bar down in behind the bumper cover. So there's a molded cover that looks like it's right at home when you have the light covered up, and then when you undo the two quick connect fasteners, you take the cover off, and there's a light hidden in behind the bumper cover, which allows you to have that for off-road use. We've added some other lighting in the rear bumper, some ditch lights on the truck to really accent that. And then on the front grille was the biggest push for the new lighting, the accent lighting of the vehicle. When you walk up to it, you hit the lock or the unlock button, you get a little animation sequence that welcomes you to the vehicle and lets the customers know, hey, I bought something special. So
yeah, love it. And when you're putting all of this stuff together, obviously additive is part of that, but I guess it kind of works in conjunction with other manufacturing methods. It's not kind of the only tool you go to. I mean, maybe it might be in the future. Let's hope. But I guess you've got some other things that you produce with. But how does that mix work between additive and traditional?
Well, usually during our development process, we definitely use additive now for our prototype parts. So as soon as
Yeah.
we come up with a conceptual design, something from the studio, they'll have a render. We'll turn that into a 3D part. Then we'll go and we'll print that part. Then we have to work on getting a vehicle where we can do our fitments and make sure everything looks good. We'll do some trial fitment, make some adjustments to the design as needed, and then after that, if everything looks okay, then we'll go into the traditional injection molding or thermal forming of components.
Mhm.
Then, depending on the complexity of the part, we'll come up with maybe a 3D printed part or two on the vehicle that we'll put into production, rather not just prototype, but we'll prototype it first. We'll see, hey, that worked out really well. Why don't we go down that path, right? If we can print this in mass rather than tool it up for the tooling investment,
Yeah.
if it makes sense, that's the path that we'll pick.
I mean, that's the dream, isn't it? You move away from tooling, you move away from like multi-piece assemblies, and
Right.
you can just print this thing and fit it. I love that you guys are doing that. What sort of parts are you actually putting on the truck at the moment that are additive?
Right now, what we're using is a brackets for mounting the front camera and the grill because of the angle of die draw for the tool opening of the grill. The camera was pointed down at about a 35-40 degree angle, which would add an extra slide in the tool. So in order to get the slide in the tool right in the center of the grill, that drives tooling costs up. So
Yeah.
why not create that as a secondary component that we can print? We can get the angle that we want, keep everything in the position as it was originally designed. So that way you're not changing the vision system of the vehicle. And from there, you get a nice part that fits the design intent, fits the requirements and the functionality that we need for the systems that we're impacting.
And was there kind of any discussions that you guys had internally, like, we need this thing to stand up to some pretty, heavy duty applications, because by the nature of the vehicles you produce, they might sort of see some out of regular use, let's say, kind of off
Right.
road, on road, maybe I don't know, sort of see. I don't know how you guys use the cars, but maybe driving them a bit faster and more aggressively, let's say, safely on the track though, than you might see otherwise. Was there kind of that conversation of to make sure these parts are gonna last?
So very, very much so, Justin, as part of the design validation plan that we use for the components, and that goes into the design criteria as well. So with the 3D printing, we can get away with thickening up different sections of a component to strengthen it. We can add ribs into the part to give it the structural integrity that we need for components. So,
Mm.
typically when we do a injection molded part, it's between 2.5 to 3.5 millimeter wall thickness to get consistent material flow through the tool. When we do the printing, we can go 3, we can go 4, 5, whatever we want, we can
Yeah,
thicken up. So if there's a screw boss that we want to make sure is extra strong, make it thicker. If there's some ribs, beef them up. So that way we don't have any issues when we're doing our durability testing to make sure that component will live for the life of the vehicle.
yeah. And was are you able to kind of keep up with it in terms of producing that many, to keep up with the volume, the throughput that you guys need? I guess, on the grand scale of automotive, it's still relatively kind of that small to medium volume. But yeah, is the volume kind of concern, was it one that you're worried about, or it was fine?
Uh, Again, depending on the size of the component, that kind of drives the volume equation as well. But with our volume, we're kind of a low volume niche manufacturer, so we're not in the tens of thousands, but more a couple of thousand components a year. And that printing process allows us to utilize that technology to keep up with our demand for supply, to keep up with production, and you can keep the parts coming just in time to keep the line moving downstairs.
So, Luke, I wanted to ask you as well about advice you might give to aspiring engineers. Obviously, you've had a bit of a dream career, and dream start, but what's kind of advice would you have to, the younger people watching this that might think, yeah, man, I'd love to, have a bit of a career like Luke and be working on these cars.
I'd say don't be afraid to get your hands dirty.
Mm.
So it's not just about what you learn in the books, it's what you apply with the knowledge that you're learning. Go out to the garage, take your car apart, take your lawnmower apart, take your bicycle apart, whatever it is, and start there. Because once you can understand the mechanics of how the parts function together, now you can start making the changes that you want to adapt them for your needs. And it goes for anything, whether it's mechanical, electrical. Don't be afraid to get your hands dirty.
And do you expect kind of electric vehicles to have this same sort of community of tinkerers? I mean, maybe it exists already where people are, beefing up the motors, maybe changing out the batteries and things like that. Is that next generation going to be, kind of more focused on that side, or they're still coming back to kind of your hydrocarbons?
I think it's a mix of both, because I see it even with my own two sons. They're
Okay.
17 and 19, and they're into the cars, but they're more open and welcoming of the electrification. I don't think that the ability to modify the electric motors and the systems within that cars has kind of been fully understood yet, because everyone is doing something so different that each manufacturer's got their own little way of doing things. And there are people out there that are they're tinkering with these things. They're fast. They're a blast to drive. Whether or not the aftermarket will pick up on, how can I get a piece of that new performance that is out there. I still think there's a place for the internal combustion, for hydrocarbon, like that. Will always have a spot, especially here in America. You're not going to get rid of that anytime soon. But I think the market for electrification, for alternative fuels, hydrogen, that's growing as we develop new technologies and push those boundaries. But I'll stick to the big V8 in my truck.
Yeah, absolutely, absolutely. No, automotive kind of engineer at heart. I love it. Where do you kind of sit on the whole hydrogen powertrain kind of argument? It always seems like it's up and coming, always kind of 5 years away, and you kind of wait 5 years, and it's still a little way away. Do you see it as a real alternative, or perhaps?
For sure, I do. I think the alternative fuels are definitely something that are getting pushed. Within Roush, we've got our Roush Clean Tech group, which works on alternative fuels. So, there are projects going on where we're actively seeking and working on different opportunities for future growth, whether it's propane, hydrogen, other fuels that customers are looking at. It's definitely, it's not going to happen tomorrow. I think the infrastructure is a big part, just like with electrification. The push for electrification was there from the government, the customers, but then the infrastructure isn't there to support that, right?
Mm.
So it's going to be definitely a growth curve over time to get that into place. But there's definite opportunity within the alternative fuel space for different internal combustion style engines to replace gasoline, or to take a market of that segment from gasoline.
And if you were to try and kind of guess, almost, or educate to guess, a big innovation that's coming within the automotive industry in the next 5 years, if you were to say, Justin, look out for X, is there something there that it's just over the horizon that you guys are working on?
I think the biggest thing maybe coming down the pipeline is the autonomous driving within the vehicles, as that technology is growing leaps and bounds over the last 10 years. It continues to evolve. Every new model of vehicle that comes out has better sensing, better controls, and I think that's where we're going to see the next kind of level of push will be. How do how do we develop those systems? What are the safety requirements for those systems? How do we, validate all of this, autonomous driving so I can jump in my car and drive hands free and, you know, get to where I'm going safely. I think that is a big push, definitely in the coming 5-10 years. You're going to see a big change in that market.
I totally think you're right. I've read in numerous places, our children could be the last generation that are drivers, which is
Yeah,
pretty scary, isn't it?
yeah,
But I guess it's scary in the one sense, but then less scary when you probably look at there's going to be almost net zero, road collisions and stuff. So yeah, that's the flip side. Um, yeah, and is that something that you guys are kind of doing any R&D on? Looking at driverless, or are you kind of leaving that to the OEMs for the time being?
For now, we leave that to the OEs, and then there are different customers that we are working with within our engineering services side that we are supporting for things of that nature. But within Route Performance right now, that's nothing that we're adding to a vehicle. We're just trying to make sure our products integrate with it, and that we, can prove the transparency to the functionality to make sure everything's as intended.
And I suppose another trend that I should probably definitely cover is how many parts can be made from additive manufacturing on cars going forward. Is that something you think, could increase?
No, for sure. I think the with the material advances that we found in additive, all the reinforcements that can be printed these days. You've got some your metal parts, you've got your plastic parts. It's really incredible to see what we can do with additive manufacturing
Yeah.
with the technology today. I had the opportunity to go to a conference in Chicago last year for additive manufacturing, and I was blown away by the amount of products that were not OE. I'm, focused on the automotive stuff in my day to day, and I got the chance to see how different industries are also using additive for their products, and it really opened my eyes to the opportunity that additive manufacturing has within the marketplace. There's all sorts of things every day, components, products that customers would want or use that additive manufacturing would be a great solution for.
Yeah, I feel like it's kind of almost siloed at the moment. Different customers doing many different applications. Like you'll have agricultural equipment, construction equipment, sort of mainstream automotive, doing aftermarket stuff. You'll have motorsport.
Right.
I think these conferences are great when it kind of brings everyone together and you can just openly have that discussion of this is a challenge or a concern I have. How did you overcome it? And yeah, I think definitely, hopefully in the next 5 years, that kind of community, I think that's something we'd like to grow from a Stratasys point of view. Hopefully we could, break down some of those silos and do some of that sharing between us.
Yeah, I think that you hit the nail right on the head. Is that forum for communication between the different industries, whether it's aerospace or agriculture. Everybody's just looking to solve a problem, and then when you can see how somebody else has solved that problem, that sparks an idea in your mind of, oh, I could maybe apply that to my issue at hand and turn that into a solution for whatever it is that we're working on.
Yeah, absolutely. And it's cross industry as well, like as you say, you can get aerospace and defense in there and
Yeah,
even kind of your consumer electronics and maybe more consumery type product design companies, they're doing stuff that they're perhaps installing in a car interior or that you think could be. So yeah, it's that knowledge sharing. We definitely need to kind of work on that, I think. And tell me, I don't know if you'll know so much here. Do you do much in the way of DFAM, design for additive manufacturing? So instead of kind of doing like for like parts, you're really kind of honing it for what additive can do.
in some cases, if we know up front that there's an opportunity where we can use additive manufacturing, we will design it for additive manufacturing.
Mhm.
A good example of this is our new Super Duty that we're working on to launch here in June. That's going to have some additive manufactured components on it. And just from the get-go, we said, that's the method based off of the volume that we're looking at for the program.
Mhm.
Let's not do a hard tool. Let's go straight to additive. The volumes make sense. The piece price, once we went back and forth a couple times on trying to hone it into the proper print method orientation, you can, optimize your components per print pad. It makes sense. So yeah, as we look at parts, we definitely do the DFAM. So that way the parts are from the beginning set up for that method versus a traditional cope and drag in a tool, and then we
Yeah.
can modify it to fit the printing process. Yeah.
And when you're designing generally, do you design with a manufacturing process in mind? Like I'm going to make this part, I know I'm going to have to injection mold it. Therefore, I'm going to make that part of the design. Or do you just kind of design the optimum? I just need it to be like this. And then you figure out how you can make that thing.
I think that's a big part of what we do up front in the program. So as we're working with the studio team, they're coming up with ideation. This is what I want. That's when the engineering team is getting involved and saying, okay, well, how do I deliver that? That's going to have to be an injection molded part because of the tolerances, or is that going to be a thermal formed part because of the aesthetic of the component? How can we turn it into a production piece at the lowest cost? We take that into account and figure if your tooling investment, your component piece price investment, if you have to finish the piece price, right? With additive, you can take 3 pieces that would be snapped together and print that all as one piece and not have to worry about sink or blemishes in the A surface of the part. You can make it thicker. You can add the ribbing, the structure that you need on the back of the component to clip things in. Whereas if it was a molded part, you may have to make it multiple pieces, so you eliminate some of those errors or
Yeah.
design criteria within the molding that
Yeah.
force you to turn it into multiple components. So
Yeah.
if you can reduce the number of components, that's always a good thing too.
So, Luke, we're about up on time, but I just wanted to say thanks ever so much. I just loved our chat. It's been great speaking to you, and yeah, finding out more about Roush and the projects you've been up to, part additive is playing, and yeah, how you've just got this culture, I feel, of kind of embracing innovation within Roush, and it's just great, and I absolutely salute you for it. So yeah, thanks ever so much for joining, and yeah, I hope to have that glass of whiskey with you. Actually, I might not be Henry Ford, but yeah, we can definitely share a few stories for sure.
Oh, so thank you for having me, Justin. And yeah, I'll take you up on that next time I'm in your neighborhood.
Yeah, sounds good. Great stuff. Thanks a lot, Luke. See you soon. Take care.
Thank you. You guys have a great night.